notional of the swap, I need to get into, okay, to perform a hedge as efficient as possible, perform a minimum variance hedge for the bond. If you didn't know anything about this, okay, and I told you I have a 10-year swap and the 10-year rate variance is 60 basis points, and I have a 7-year swap and the 7-year, I have a 5-year swap, say, and the 5-year variance is 60 basis points, okay? 10-year standard deviation, 60 basis points. 5-year standard deviation, 60 basis points. My bond notional is 100 million. How big should my swap notional have to be in order to perform a minimum variance hedge? What would you intuitively say? Yes, but I'm saying intuitively. Not go through that, just intuitively. Wouldn't you say, I'll just need to double my notional? That would be your first intuitive thing. Say my volatilities are the same, my 5-year has half of the sensitivity, so I need to double my notional. This would be almost correct. What this assumes is that rho AB is 1. Okay? Because I can have my 5-year swap rate to have 60 basis points volatility, my 10-year swap rate to have the same, but to have zero correlation. This is mathematically possible. It could be that I have an interest rate curve which goes like this, which is crazy. It doesn't go all up or all down, it's just crazy. Generally, this doesn't happen, but you made an assumption in this intuitive answer that rho AB is the same. The one way to hedge is called duration matching. The other way to hedge is called minimum variance hedge. Okay? Duration matching also has its uses. Okay? We will go through this formula here, and then we'll discuss a little about the uses of duration matching. Okay, in this case, if we differentiate with respect to NS, what would we have? This term here, no bearing whatsoever. Okay, this thing here would say that ds 1 over 10k, I call it, right? 10,000, that's right. Times sigma 7 squared. Okay, minus. I'm sorry, my fault, but there should be a square here. You guys don't correct it. So it could be that ds, let's say, ds 1 over 10,000 squared times 2ns, okay, minus 2 sigma 10 sigma 7. Sorry, sigma 7 squared times this minus 2 sigma 10 sigma 7 rho and b. NS is not okay. dB. Yes. I say, for argument's sake, that this is 1. Okay. Times 1 over 10,000 squared. Okay, this is my derivative. Okay. So for this derivative to be equal to 0,
with respect to
this is my derivative with respect to NS. So for this derivative to be equal to 0, let's just do some simplifications here. This goes out. this 1/1000 goes out. This 1/1000 goes out. And I have, NS equals. So this equals that. This one is 0. So I have NS equals rho NB dB ds over ds squared. Does this start making sense after a while? Times sigma 10, sigma 7 over sigma 7 squared. Or I can write it here. Here, then S equals rho NB dB over ds times sigma sigma b, let's hold it like this, or sigma s, which is very, very close to this. Except for two things. There is no minus sign because I have already assumed that the interest rate direction of the swap is the opposite. Make the minus sign. And B, and instead of having sigma, the ratio of the sigmas is the ratio of the sigmas of interest rates times the durations. Simple as that. It's just that everything has to be scaled by the duration. Now, if rho is 1 and the ratio of the sigmas is 1, then my minimum variance hedge, okay, is essentially a duration matching. It becomes NS times ds equals NB times dB. In general, though, my minimum variance hedge is not the hedge that matches the durations, because, first of all, I could have different a priori volatilities in interest rates, or even if I have the same volatilities, I could have imperfect correlation. At the limit where the correlation is 0, I cannot hedge at all. It's exactly the same thing as having a stock which has 0 correlation with the index. I cannot hedge at all. Same thing here. The thing is, and I don't have it ready, the proof in my mind, but the thing is that if you try to do the minimum variance, you get the same thing. That the perfect hedging of a bond, okay, it will reduce your variance to the variance of the bond times 1 minus the rho, the correlation coefficient between the interest rate which is applicable to the swap and the interest rate which is applicable to the bond. So again, if I tell you, forget what we have now, what you heard now. I got the interest rate curve, okay, has 0.9 coefficient between the movements of the 5-year and the 10-year interest rate. Okay? I'm not telling you anything about the volatilities. Okay? What is the maximum amount, actually, what is the minimum VAR that I have a 10-year bond and I'm trying to hedge as best as I can with a 5-year swap. My 10-year bond has a VAR, I don't care how calculated, of 100. How much is going to be the VAR of my minimum variance hedge?
40.
40. I didn't tell you anything about the respective volatilities of the curve, because the respective volatilities are going to be captured inside the notional amount of the swaps. So, I think this takes some time to digest.
Yeah. Hello.
It's the same thing. I mean, in the equities and the index, it was pretty obvious. In the bond wise, it's not obvious. It's just like an equity, kind of. It's just that the scaling between risk and actual dollar impact is scaled by the duration. So, we are going to begin the solution to a problem. It used to be practice review problem. We are going to do this as a homework problem, or let's call it assisted homework problem. Okay? Again, we can have many efforts, many tries of this. It doesn't have to be ready the next class. Okay. Suppose we live in a world where the interest rate is composed of two tenors. In practice, the interest rate curve has many more tenors, and a very strange connection between the different parts of the interest rate curve. But suppose we have only two tenors, the 5 years and the 10 years. Okay? I am giving you the 5 and the 10-year rates in a spreadsheet, which is in E-class. I think it's called assignment interest rates. Do you have E-class? It is one of the things that were uploaded yesterday. So you have the 10-year, the 5-year, the 10-year. Okay? You will be asked to find the daily variance-covariance matrix assuming 1 year unweighted observations. Okay? We'll begin to do that. Now, I have a position of a 10-year bond at par. It's called a hedged item. And I need to duration hedge it with a 5-year swap. It's called a hedging instrument. Okay? What's the notion of the swap? What's the daily var of the combination? The same if instead of doing duration hedging, I did a minimum variance hedging. We saw that these two are not necessarily the same thing. And now the fun part starts. There are certain accounting rules which are called fair value hedging rules. Fair value hedging is an accounting activity. Okay, have you ever heard of it before?
No.
It basically says that if I have a bond in a portfolio which is not marked to market, which means I don't need to disclose movements of this portfolio in my balance sheet as P&L items. Okay? The derivative can basically follow this bond in the non-marked to market portfolio, okay? As long as the movements of the bond and the derivative are within 25% of each other. So the movement of the bond is between 80% and 125% of the movement of the swap, or the opposite. It's exactly the opposite. Now this is a true accounting rule, I'm not making it up. This is actual IFRS accounting for both America and Europe. Whenever I have such an imperfect hedge, okay, the first thing the management asks is, what is the chance that the so-called hedging effectiveness, which means the things diverge, is going to be so big that it will come and contaminate my income statement? So, in this exercise, we'll do a historical simulation and we'll see what are the chances of actually my hedging relationship to fail and for the results of the interest rate swap to come and contaminate my interest rate. If I remember correctly, this was last year's exam, only it was not a historical simulation, it was a Monte Carlo simulation for the probability of contaminating the interest rate. Okay, let's open it. How about let's see. Do you prefer to think about this on your own and come back next time, and today we finish what we started next time? Or do you prefer to get a head start on this?
Get a head start.
Get a head start on this, okay. Okay, let's get a head start on this. So let's open up the... Let's open up the... Let's see, can I open it up? Here. It's called interest rate test case performance. This will be. Oh, has it?